Hey guys, welcome back. So we're going to continue the 7.2 notes. So these notes are going to be the same ones that you started last week. We're just going to pick up where this one left off. So this is actually 7.2b. So before we get started, just to kind of refresh your memory, go ahead and solve this one by completing the square. So just pause this here and try to do this one on your own before you continue. Okay, so the first thing you got to do is we've got to move the negative 92 to the right hand side. So we're just going to add that to both sides. Remember, we're going to leave a space here to complete our square. So 92 is on the right, and whatever we add to the left side, we're going to add to the right side. Okay, so now what we're going to do is take our b value, which is negative 14, and we're going to use that little expression b over 2 squared. So in this case, we're going to take 14, divide it by 2, which is 7, and square it, which is 49. So we're going to add 49 to both sides. Okay? Now what that's going to do is give us our perfect square trinomial on the left. So that's going to factor down to x minus 7 times x minus 7, or x minus 7 squared. And then we're going to add the 92 and the 49 to give us 141. And now to undo the square, we're going to take the square root of both sides, right? So we're going to have an x minus 7, and we have to do the positive and negative version of that answer. So we're going to do plus and minus the square root of 141. Okay, and we can't simplify 141. There's nothing that really breaks down into that. But we do need to add 7 to both sides. So plus 7 and plus 7. So our solution ends up being 7 plus or minus the square root of 141. All right, so what 7.8 was dealing with was when we had a quadratic equation where this leading coefficient, this number in front of the x squared, is a 1. Okay, so what we're going to do today is solve equations where it's not a 1. So what do we do when that lead coefficient is not a 1? And it's pretty much the same process, but we do have a little bit of a change. Okay, so this is going to be our kind of test example here, 3x squared plus 16x minus 92. So it looks similar to the last one, but now you see we have this 3 in front. Okay, so here's the steps that we're going to follow. We're going to make sure that that lead coefficient is a perfect square, because currently it's not, right? It's a 3, that's not a perfect square. So we're going to have to change that. Then we're going to square, okay, so we're going to solve that issue by squaring the lead term. That's what we're going to do here. Okay, so how are we going to do that? Well, in this case, for this one, we're going to multiply it by itself. That's the easiest way to make a perfect square, right? So 3 times 3 would be 9, which would then be a perfect square. But we have to remember that we're going to multiply the entire equation by that same number, because we got to make sure that we maintain that equality. And then the other change we're going to make is, instead of b over 2 squared, we're going to use this expression of b squared divided by 4 times a. Okay, and it's always going to be a 4, so just make sure you make a note of that in your notes. And then we're going to solve exactly like we did before and solve the rest of it just like we did. So the two main changes here is we have to have a perfect square in the front, in the lead coefficient. And the other change is we're going to use this expression of b squared divided by 4a. All right, so that's what we're going to do with this equation. So the first step, as I said, is we're going to multiply everything by 3. You might ask, well, where'd you come up with a 3? Well, I want to make sure that this first term, 3, is a perfect square. So I'm just going to multiply it by itself to give me a perfect square. So we're going to use distribution here. So 3 times 3 is 9x squared. And it's kind of early when I'm doing this. So 16 times 3 is 48, so plus 48x. And then 92 times 3 is going to be a negative 276. And then, of course, 3 times 0 is just 0. All right, so from here, the process is almost the same as what we've been doing. We're going to add the negative 276 to the other side. So 9x squared plus 48x plus some mystery number that we're going to determine equals 276 plus whatever that same number is, okay? So the other change here, and please make a note of this, highlight it, circle it, whatever is going to make it stand out. We're going to use b squared over 4 times a, but this is the note I want you to make. We're not going to use the original numbers, okay? Remember, this is a, b, and c, so a, b, and c. We're not going to use the original numbers. We've changed the equation a little bit. We changed the way it looks. So what we're going to do is we're going to use the new numbers of 48 as the b and 9 as the a. So if my b squared is going to be 48 squared divided by 4 times 9, because 9 is my a value. All right, and that is going to be a pretty big number, but that's okay. So 48 times 48 is 2,304. And don't worry, this is going to get smaller here when we divide it. 4 times 9 is 36. So we're going to divide 2,304 divided by 36 is going to give me 64, which is a much more manageable number. And it's a perfect square. So we're going to add that to both sides. All right, so we now have our perfect square trinomial. So this is going to factor down. If you remember the pattern, I'll write it down one more time. It's a squared plus 2ab plus b squared, or it could possibly be minus 2ab plus b squared. But either one of those, this one would factor down to a plus b squared. This one would factor down to a minus b squared. So this one, 9x squared plus 48x plus 64, is going to factor down to 3x plus 8 squared. Okay, again, you could factor this the long way, but save yourself some time and start to recognize the pattern. If you just take the square root of the first term, right, 3x times 3x is 9x squared, and 8 times 8 is 64, it's going to factor down to 3x plus 8 squared. And then we need to add 64 and 276, which is 340. And then from here, it's the exact same. We're going to take the square root of both sides to get rid of the square. And whatever I do to the left side, I do to the right side, so square root there as well. And that's going to give me a 3x plus 8 equals plus or minus the square root of 340. Okay? Now, I do need to see if 340, because I know it's even. So let's see if we can actually simplify the square root of 340, right? So divide it by 2. And we get 170. 170 is 2 times 85. 85 is 5 times 17. So it looks like the only thing I can do to simplify this is I have two 2's, so I have a pair of 2's. So this is going to simplify to plus or minus 2, because it gets to move out, times the square root of 5 times 17 is back to 85. All right, so we just did a little simplifying there. We're also going to subtract 8 from both sides, so I'm just going to put it in the front. Okay, so negative 8 plus or minus, that's a plus. Plus or minus 2 times the square root of 85. And then, of course, I still have 3x on the left, so I have to divide everything by 3. And when I say everything, I mean the entire expression on the right needs to be divided by 3. All right, now in most cases you're going to be done here, but you do want to check to make sure we don't have any fractions that can be reduced. So I look at my three numbers here, and since 3 doesn't go into 8 or 2, then I know that that's as simplified as I can make it. So this would be my two solutions, okay? Negative 8 plus or minus 2 radical 85 divided by 3. So the solutions are going to look a little longer than what we've been dealing with, but at its root, it's the same kind of process, right? The only difference was we had to multiply by 3, and then, of course, our expression that we added up here, right, that changed a little bit as well. And that's the main difference between the two. If you have a number in front of the x squared, like we did here, we have to deal with that. We have to make it a perfect square, and then we change our expression. Okay, so here's 2 for you to try. So go ahead and pause this and see if you can do these on your own before we move forward. Okay, so the one on the left is a lead coefficient of 5. So to make that a perfect square, I'm just going to multiply everything by 5. So that's going to give me a 25x squared plus 30x minus 10 equals 0. All right, so then we have to move that negative 10 to the right. So 25x squared plus 30x plus something equals 10 plus that same something. All right, so we're going to use the b squared over 4 times a, and that's going to, remember, we're going to use this new b and this new a, okay? So 30 squared divided by 4 times 25. So 30 squared is going to be 30 times 30, so 900 divided by 4 times 25. 4 times 25 is 100. So I know they look big at first. They're always going to kind of get down to a perfect square here. So we're going to add 9 to both sides. All right, so that's going to give me a perfect square trinomial because I have a perfect square here and here. So this is going to factor down to 5x plus 3 squared, and it's equal to 10 plus 9 is just 19. And then we're going to take the square root of both sides again. So 5x plus 3 is equal to plus or minus the square root of 19. 19 is a prime number, so we can't simplify that one, so just leave it like that. But I am going to subtract 3 and then divide everything by 5. That way my x is by itself. So x is equal to negative 3 plus or minus the square root of 19. Don't forget the minus sign like I did. Plus or minus the square root of 19 divided by 5. All right, second one. Let's give ourselves some separation here. We're going to multiply everything by 2, right, to make a perfect square. So 4x squared plus 20x minus 26 is equal to 0. And then I'm going to move the negative 26 to the right. So 4x squared plus 20x plus something equals 26 plus that same something. We're going to use b squared over 4 times a. In this case, the b is 20, so 20 squared. And we're going to divide it by 4 times a, so 4 times 4. 20 squared is 400. We're going to divide that by 16. And for the life of me, I can't remember what that is. So 400 divided by 16 is 25. I should have known that one. So 25 gets added to both sides, which is a perfect square. So we're going to factor this left side to 2x plus 5 squared. And the right side is just going to be, 51 if we add 26 and 25. All right, so then we're going to take the square root of both sides, which is going to undo the square, so 2x plus 5 equals plus or minus the square root of 51. Then, of course, we have to subtract 5 and divide by 2. So now x is by itself. All right, so hopefully you did those well. And if not, please make sure you're asking questions, because I know completing the square is kind of a lengthy process, so it's easy to kind of get lost in the whole process. I know it's long. So you guys have a good day, and I'll see you in class.